let's discuss the rules on least precisely measured values. So you might notice we got 28 or 30. I said both are correct, but 30 is more correct. Let's talk about why that is exactly, and the other rules as well. So least precisely measured values. Rule number 1, do not round until your final answer. This is a rule we kind of break often in class, but in the real world, it's very important. If you round every single time, it's going to change the answer a little bit more as time goes on. It's kind of like the telephone game, right? You guys played the telephone game before? You sit in a circle, one person whispers in the next person's ear some message, and then by the time it gets back around, everybody whispers, tries to repeat the same message. The answer's changed completely. Same thing happens if you round every time you get an answer on your way to the answer, so partial answer, whatever. You get the idea. Second rule, when you are adding and subtracting, you use the precision of the least precise value. Of the least precise value. So, for example, we didn't add or subtract in this, we multiplied in this, but we only had one value we were given, 3. What's the precision of that number? Well, it's a whole number, right? Exactly. It's one digit. All right, and when you're multiplying and dividing, multiply or divide, you use the precision of the measured value, with the least number of digits. So that W dash is shorthand for with the least number of digits. And what we're talking about is, you've probably learned it as significant figures. Least number of digits. And so you can see this happen actually. So this only had how many digits? How many significant digits does this number have? So that's why 30 would be the more correct answer, because that also only has one sig fig. 28 technically has 2, although 28 is closer to the center answer, right? We go from 22 to 35. Both are 5 away. 28's right in the middle. I would accept that. It's technically wrong. 30 is the significant figure. Clear? Let's do another example using both of these. Let's draw ourselves a rectangle. And let's say this rectangle is 4.28 inches tall. And let's say it's 9.0 inches wide. I've got 2 questions for you. What is the perimeter? And what is the area? I'll give you a second to catch up with me. So what's the formula for perimeter? You add up all the sides. Well, this side is twice, this side is twice. So it's 2 times this number plus this number. Essentially, we could just say 2 times the height plus the width. So 2 times 4.28 plus 9.0. Let's go ahead and do that in our handy-dandy calculator. let's say 2 times 4.28. Can y'all see that? 2 times 4.28 plus 9.0. And we get exactly 26.56. Here's the deal. That could be 9.04. It could be as big as that. It could be as small as 8.96. And we'd round that to 9.0. It could be anywhere between those values. So how certain are we of that third digit? I'm sorry, that fourth digit? We're not. At all. So what will we round to? 26.6. Very good. We'd round to the number with the precision of the least precise value. I've got two numbers. This rounds to the first decimal place. This rounds to the second decimal place. This number is less precise. We're going to use that precision, the first decimal place, when you are adding and subtracting. Area is base times height, or height times width, essentially. So we're going to say just 4.28 multiplied by 9.0. And let's go ahead and add inches there. So let's plug that into our handy-dandy calculator. We'll say 4.28 times 9.0. We get exactly 38.52. But here's the deal. Again, we are not certain of that fourth decimal, that second decimal, the fourth digit. We're not certain at all. What will we round to in this one? So it's either 38.5 or 39. Those are the two answers I heard. Here's the deal. When you multiply, digits move. Are y'all with me? The digits move around. So I'll draw this. You don't have to write this, but let's say we said 3.0 times 10. That would make it 30. Does that mean we round to the first decimal place? Well, no. We're not certain of that. It would change. This could be 3.01 for all we know. That would make this 30.1. We're not certain of that. The digits, well, move as you multiply. So this is why we use the least number of digits. This has two digits, two significant figures. We will use that precision. So 2 digits, this rounds to 39 inches squared. Savvy? And then go ahead and tape this in for our last example for these notes.